Afternoon, fellas on YouTube. Here's a quick video for a fella in Alberta who picked up a takeuchi 216, and he has some questions about pins, materials, grease holes, failure modes. So I've got the pins that I broke here and the ones I didn't break lined up on the milling machine here just to show you the sequence of events. So I picked up the machine used. The relief pressure was set to match the hydraulic system pressure, which is about 3,100 psi, and I tested it and I verified that the pump and everything is working good. So sequence of events here is I broke this original pin, which may or may not be made out of 4140. I don't know for sure. It definitely was hardened. The machining methods was to counterbore the grease hole. The grease hole was drilled all the way through, and there's a galley which goes down this side of the pin, which would be on the right side of the boom. And this side is greased only to about here. This is where the bolt hole passes through here for the coupler, the takeuchi 27 coupler, and then the grease hole travels all the way down here. And then obviously this is not drilled all the way through. All right, so that broke right there. And I should say I broke this pin probably after I replaced the dipper stick bushings. And I do believe my dipper stick bore was a little bit wallowed out. So I put in new bushings and I put them in with Loctite 603. So they were tight. Nothing was moving around there. And I staked in the seals and everything was nice and tight. So just by tightening up the bushings, I think I gave no place for this pin to flex or wobble around, and I took out all of the movement that was possible, so the movement had to go through the pin. So it broke right there through the grease holes. So I ended up picking up some 1045 induction hardened chrome bar, and I drilled through it, but I only drilled one side all the way through for the grease to exhaust. And induction hardened chrome bar is C1045 or 1050, and it's induction hardened to about 100 thousandths depth, and it's chrome plated, and I only think that's about 5/10 thousandths of an inch thick. Anyway, to be able to machine that, I use a ceramic insert to be able to get through the induction hardened layer, and then you can machine as normal on the lathe. And to drill the holes, I use the carbide end mill to get through that hardened layer. Just take your time and use the right feeds and speeds, and you should be able to get through that hardened layer no problem. Anyway, I broke that pin. So I was like, all right, well, that's no good. So I made another one, and I used a smaller diameter hole, and I relieved the hole here with a ball end mill, just to give it a bit of radius. And I used a smaller hole, but I still broke it. So I bought a hydraulic test kit. I adjusted my thumb relief pressure so that it would drop the pressure to the point where I could curl the bucket and it would retract the thumb. And I didn't have any problems after that. And at the same time too, I also replaced that pin with this pin. And this pin has no gallery all the way down the middle and has no hole in the middle. I have a hole drilled and tapped in my dipper stick with a grease zerk, and I greased through that to be able to get grease into the pin and the bushing in the dipper. So this is the same thing, less the hole all the way through, less the hole through the side. Now this one is slightly bent, and I think at one point I didn't have the hydraulic pressure adjusted quite right, but I bent it slightly. We're talking maybe 30 thousandths of an inch over the length of it. There's a bow in it, and that's not really going to affect anything, and bending slightly is obviously much better than snapping in two. But this is ultimately the successful design mod. And from what I understand is Kubota used the same style greasing system to get the grease all the way through the pin, and they would break in the exact same spot. So my recommendation is to either use 4140 or 1045 induction hardened chrome bar, but not to drill the hole all the way through and intentionally weaken this pin. And my advice is to obviously also reduce the pressure going to the thumb. And I believe the gentleman used a smaller diameter bore cylinder, so he develops much less force over the OEM tag one, which develops much higher force because it's got a larger bore. All right, so that's my information on excavator pin drama and how I was able to ultimately solve my problem. And like I said, I've got a new system with the wedge coupler, and I've got a new pin installed on the machine itself. And we'll put this thing to work here shortly as soon as the season opens up. And I'm very, very hopeful and confident that I have solved the issues with breaking pins and increasing the tightness of the whole system here. All right, guys, thanks for watching.